Okay, these videos are going to be on similar triangle problems and specifically with a focus on proving, and they relate to questions from your book. So this first one that I'm going to look at is from page 331 and it's question 15. Now, with these questions, what I'd advise you to do is first of all draw the diagram into your own copy and have a read of the question and see how best you can manage it yourself first. I would suggest begin with these questions generally by trying to think about the theorems that you've used in the past and apply those so that you can identify any equal angles. And remember, like what we've done in class, you can mark the angles with different symbols. You don't need to necessarily know how big they are as a number. Just annotate them in the diagram. If you get stuck, well then maybe play a bit of the video and play enough to give yourself a hint or a prompt, and then pause when you've got the idea of how you might be able to proceed. And so kind of drip feed yourself, as it were. Don't watch the whole video in one go. Watch it bit by bit to kind of give you a push towards how to do it, okay? And don't forget, once you've done that once, you can do it a second time as well to try and get a more fluent understanding of what's going on. So the diagram is drawn here, and it's the same diagram as you have in your book. They have told us in the book that AX is equal to XB, and we're trying to prove that AB is parallel to DC. So I'm going to start by not writing anything down, but instead just first of all trying to identify things in the diagram that are equal. So I'm going to note here that, for example, this angle at A must be the same as this angle at B because it's an isosceles triangle. And once I've identified that in the diagram, I'm going to make a note of it. So I'm going to say, okay, the angle XAB equals to the angle XBA. Why is that? Well, that's because I've got an isosceles triangle. So don't forget, if you're making a statement about something, that you need to give a reason as well. Okay, so the next thing then is think about the theorems that you've dealt with involving circles. So we can say, for example, that theorem 19, one of the corollaries, allows us to state that angles standing on the same arc are equal in size. So I just have to identify if there's any of those in the diagram. And I can see actually that, yeah, I've got an angle here standing on an arc and an angle here standing on the same arc. So let me just identify where that arc is. That's the arc there between B and C. And there's one of the angles, BAC, or I'm going to call it BAX in a second just to kind of keep my notation the same. And there's the other angle there at D. So I'm going to mark those with the same symbol. I've already marked this guy at A, so I'll just mark this one at D in the same colour. Okay, so what can I say there? Well, I can say that this angle is called the angle XAB. So XAB is equal to XDC because they're on the same arc. Now, I can do that from the other direction as well. So I can also see that this angle here stands on the same arc as this angle here. I'm going to draw that in. There's my arc, and this angle here stands on that arc, and so does this angle here. So I can say in that case, so that the angle in this position and the angle in this position must be equal in size. Okay, so let's have a look. So I've got this angle here, so which is XCD. And that is equal to the angle XBA. And the reason again is because those two angles are standing on the same arc. So at that stage then you might notice that this angle here and this angle here are equal in size. And that looks an awful lot like alternate angles. And this angle here and this angle here are also equal in size. And that also looks an awful lot like alternate angles. So now I don't know that these lines are parallel. That's what I'm trying to prove. But the fact that the angles in these positions are equal lets me know that I've got alternate angles. And if I've got equal alternate angles, well, that tells me that the lines are parallel. So I'm going to write that down. I'm going to say that this angle here equals to this angle here. So I'm going to say, well, this angle here is the angle XDC. And this angle here is the angle XBA. I don't need to give a reason for this. I'm simply referring to what I've already marked into the diagram. And I can also see that this angle here is equal to this angle here. So I'll write that down too. So, and the angle XCD equals to the angle XAB. So now I'm just going to make that observation that my alternate angles are equal. And then finally, I want to draw my conclusion, and that is that if those alternate angles are equal, well, the lines here and here must be parallel. So therefore, I can say that AB is parallel to DC. And that's my question then concluded. It's important in all these questions that every time you make a decision about your diagram, that you write down the reason for it, that you write down each of your statements nice and clearly, and that you draw a conclusion at the end. But I would suggest always begin by engaging with the diagram and see what you can see visually before you begin to write down statements. Don't just start writing things down straight off. Look at what's happening here first.